Hello student, today we will discuss refraction from curved surface. Refraction from curved surface. Now what do we mean by curved surface? Curved surface means it may be concave or it may be convex. We have one convex surface here and here we have denser medium having refractive index n2. This side we have refractive index n1. This is what we call the principal axis, and this C stands for the center. If a ray is passing from C, any ray which passes from the C will considered as a normal. So it will be a normal. Now suppose object is placed at this point and object is here. This is pole. The ray will come and it will hit the prism is normal. This angle will be I and the ray will move towards the normal. So it will form image here. I will be here. We should draw always arrow. This angle is alpha, this angle is beta, this angle is gamma, this angle is R. R, it is called the angle of refraction. Now if we draw one perpendicular here, this is P1. So MP1 is perpendicular. This point is, suppose it is M. So MP1 is perpendicular on principal axis. And what is principal axis? This line. Extend here, it will be principal axis. Now we can say that MOP, triangle MOP, it is alpha, MCP is equal to MCP, which is equal to gamma, this MCP, and MCI, MCP, again it is MCP, MIP, it is equal to beta. This P and P1 are very close. So for small aperture, here only we will define for small aperture MP1, it is equal to MP. Okay, so now we can write tan theta. Here we can define that tan alpha, it is equal to MP upon OP, tan beta is equal to MP upon PI, and tan gamma, it is equal to MP upon PC. since the angles are very small, so tan alpha will be alpha only. So it will become alpha equal to mp upon op, beta equal to mp upon pi, and gamma mp upon pc. Equation number 2. It will be equation 1. Then the same diagram we will use, but now we will see how it will proceed. That means we will use to derive the exterior angle is the sum of two interior angles. Now here exterior angle is what? The exterior angle is, again we will draw diagram. See, this is our refractive curved surface and principal axis. The ray will go from this point, it will hit, this is MP. The line which passes from the C, it is normal. This will be I. Draw one perpendicular here, P1. This is P, incident ray. This angle will be R. This angle will be I. This is alpha, gamma, and beta. Then exterior angle is sum of two interior angle. Before going to that, this is N1 and this is N2, the different refractive index. And we can write sine I by sine R, it is equal to N2 upon N1. For very small angle, sine I becomes I, sine R becomes R. So I by R equal to N2 by N1. If you multiply it, it will become N1I. It is equal to N2R. We can say equation 3. Here we have one more point that we can consider. In this triangle, this is exterior angle. So we have to find out the value of I. I will become alpha plus gamma and R will become alpha plus gamma and R will become gamma. Now in this triangle, this will be the exterior angle. Gamma equal to R plus beta. From this we can calculate even the value of R. R will be gamma minus beta. This is equation 6. And then we will put the value of I here and R here. Therefore, if you put this R, this I here, so it will become N1 alpha plus R. It is equal to N2 gamma minus beta. And then we have alpha, beta and gamma. Already we have calculated alpha, beta and gamma. What we have calculated, 10 alpha, 10 beta and 10 gamma we have already calculated, 10 alpha, 10 beta. And even though we have calculated the alpha, beta and gamma, what is alpha? So alpha is this MP upon OP, beta is MP upon PI and it is MP upon PC. So we will put this value. N1 alpha is what? This MP upon OP plus MP upon PC. This is equal to N2 MP upon PC minus MP upon PI, and then bracket close. And MP is common, so it will cut. So it will become N1 1 upon OP plus 1 upon PC. This will be equal to N2 1 upon PC minus 1 upon PI. Then we will use the sign convention. What is the sign convention? This we will keep, say, equation number 7. And then we will use another diagram for that. See, this distance will be U. This distance will be U, and that too minus U. Because incident ray is going here, we are measuring this side. This will be plus R, and this will be plus V. So we will put these values in equation number 7. So first of all, we'll write equation 7 and then we'll put the values. So again, we will write the equation 7 here. N1 1 upon OP plus 1 upon PC. This is equal to N2 1 upon PC, but it was 1 upon PC minus 1 upon PI. So here, what is OP? OP is minus U. PC is plus R and PI is plus V. So when we will put these values here, we will get N1. You know why? You can draw another diagram here to make clear that it is O, this is C, so the image will be here. This is beta, this is gamma, this is alpha. So this is object to minus U. This is point P, M plus R and plus V. So we will put the value, and 1 upon OP is minus U plus 1 upon R. This is equal to N2 1 upon R minus 1 upon V. It will become minus N1 by U plus N1 by R. This will be equal to N2 by R minus N2 by V. Then you can transfer this side. So when it will come here, it will become N2 by V minus N1 by U. This will become N2 by R. Now this will come here, so it will be minus N1 by R. Finally, we can write N2 by V minus N1 by U. This is equal to N2 minus N1 by R. And we will keep this formula that the refraction takes place from the rare medium to denser medium. Here it was rare medium. When ray goes, here the rare medium, and here we have the denser medium. So ray is moving from rare medium to denser medium. It will be N2 by V minus N1 by U. It is equal to N2 minus N1 upon R. But if the refraction takes place from denser to rarer medium, in that case the thing will change. This will go here and this will come here. That we will see in the next period. Thank you.